Today we will discuss about constant energy surface. So in the previous class we have obtained the expression for energy in case of simple cubic structure, that is E of k is equal to E naught minus alpha minus 2 beta into cos kxa plus cos kya plus cos kza. See, the minimum value of E is obtained at the point ky equal to kz, kx is equal to ky equal to kz is equal to 0. That means when kx, ky, kz reduces to 0, this cosine term reduces to 1. Right? 1 plus 1 plus 1, 6. E naught minus alpha minus 6 beta, you are getting this is the minimum value of energy E of k. But however, if kx value is slightly, very slightly greater than kx, slightly greater than kx or ky or kz, which is very slightly greater than 0. In that case also we are getting the cosine terms very nearly equal to 1 only. That means cosine terms attain unity. So nearly unity, right? So because if kx equal to ky equal to kz, which is slightly greater than 0, in that case also approximately we are getting cos kxa equal to cos kya equal to cos kza nearly equal to 1. This is what we are saying. So that means arguments kxa, kya and kza must be very small in order to do this approximation. So under this approximation, that is Ka is much less than 1. So then you can go for the expansion. Cos Ka is equal to 1 minus a square by 2 factor, and so on, just like previous case we have done this. So similarly here in the place of cos kxa, you have to substitute 1 minus kx square a square by 2 factorial. In the place of cos kya, you have to substitute 1 minus ky square a square divided by 2 factorial. In the place of cos kza, you have to substitute 1 minus kz square a square divided by 2 factorial. Right. Then you have to go for simplification. Right. Then finally you will get the expression as E of k is equal to E naught minus alpha minus 6 beta plus beta a square into kx square plus ky square plus kz square. Then rearrange it for kx square plus ky square plus kz square is equal to E of k divided by beta a square minus of inside the bracket you have E naught minus alpha minus 6 beta by beta a square. Yeah, these are all the constants, right? So which is equal to a constant. So as you know, x square plus y square plus z square is equal to constant in Cartesian coordinate system represent a sphere. Therefore, in case space, kx square plus ky square plus kz square is equal to represent an equation of a sphere in a space. So that means the shape of the corresponding to this is a sphere. Then what is the speciality of this spherical surface, right? So that means as you studied in last semester, right? If the for free electrons, the Fermi surface is a sphere. That means what? If you get the Fermi surface is a sphere, then the electrons which are present inside the sphere is behaves like free electrons. That means under the approximation Ka is much less than 1, we are getting the spherical shape. That means under this approximation, the electrons which satisfies this condition is behaves like perfectly free electrons. That is the meaning of that. This is in 2 dimension. We have written the circle, but in 3 dimension it is a sphere. Okay. Now the question is whether till what condition this sphere goes, radius of the sphere is goes on increasing, right? So as the value of E increases, just to see here, if E value increases, radius of the spherical constant surface also increases, right? Because for a given value of E, it is a constant. If E increases, what happens? The radius of the sphere also increases. So therefore, but it will continue. So we are getting as E increases, radius also increases, we are getting the spherical shape. We will get the spherical shape as long as Ka must be very much less than 1. This condition should satisfy it. So if this condition is not satisfied, then this approximation does not hold good. This approximation does not hold good. Remember, that is the meaning here. As the value of E increases, radius of the spherical constant energy surface increases until the value of K associated with the point's surface becomes so great that approximation Ka much less than 1 is no longer holds good. If this condition is not holds good, then we are not getting the spherical shape. So that means here we are reaching the this one. So now, if this condition is not satisfied, then what happens is there we are getting the shape which is a little bit distorted from the sphere. So that means what we are getting is sphere expands, but somewhat distorted. That means a perfect sphere is not expected. So at this point, E is equal to E1 plus 4 beta. This condition is satisfied. If this condition is satisfied, what we are getting is quasi octahedral form. That means it has a, see, just I will show you here. This is the case. See, it is in 2 dimension, right? Only 4 surfaces you are getting. So still 4 more you have to add. Just like a roof, you are getting 4-sided roof. How it getting, right? At the upper face. Similarly, you have to imagine that roof should be closed by from the bottom, right? So therefore, here what we are getting is the octahedral, quasi-octahedral. That means so one surface is covered by another. As E value increases, this is co covered by another octahedral surface. So therefore, 8 surfaces, okay, 8 surfaces with 4 edges. We are expecting that is nothing but this octahedral shape. Okay, so this octahedral shape will continue until we are reaching the limiting value of the side 2 pi by a. That means this from 0 to pi by a, here 0 to minus pi by a. So that the total length of the side becomes what? Pi by a minus of minus pi by a, 2 pi by a. So similarly, when the energy is increasing still further, and it becomes E is equal to E1 plus 8 beta. The surface is split up into 8 sheets of each of which appearance of the corner of the cube. In the corner of the cube, we are getting just like this. See? So this is the cube at the, so it is the octant you are getting, octant like shape you are getting at the corner of each of the cube. Okay. So therefore here, remember the electrons which belongs to this sphere is having the same energy. The electrons which belongs to this octahedral, they are having the same energy. The electrons which belongs to this octant, they are having the same energy. That means in this region inside the sphere, we can say that electrons are behaving like perfectly free electrons. As the energy increases, what happens? They are not behaving like free electrons. The free electron concept started to distort, right? So therefore remember, so this is one constant energy surface. This octahedral is another constant energy surface. This octant split into 8 sheets at the corner of the cube, that is another constant energy surface. As the energy changes, the diagram becomes more and more complicated. It is just a 2-dimensional diagram. Just you can see how the octahedral comes, how the octant comes. It is just like apple cut into 8 pieces, in which one part of the apple is taken. Then that is fit into the corner of the cube. Such 8 corners a cube is having, like this. So when the energy is equal to E1 plus 12 beta, this is the constant energy surface. So sphere, octahedral, and here the octant we can observe the three cases we have discussed. This is about the constant energy surface. Thank you.